So example 2, solve an inequality. What's different about this one from the one we just did? It's got a fraction in it, right? How did we deal with fractions when we were solving equations? Yeah, we found a common denominator. We multiplied through to get rid of the fraction. It's called clearing fractions. In this case, there's only one denominator, right? That's 2. So basically, before we start, let's multiply everything by 2. Now we've got 2 minus 3x is greater than or equal to 2x minus 8. No more fractions. Okay, there's no other simplifying that we can do. So what should I do as the next step? Okay, subtract 2x. Which is bigger, positive 2x or negative 3x? The positive 2x is actually bigger than negative 3x. So again, if you go back to this slide, you know, the whole reason we always try to move variables to the side that has the bigger coefficient is so we avoid having to multiply or divide by a negative number, which means we've got to remember to flip the sign, right? So that's why in this case, yeah, you could subtract 2x from both sides. You would end up with a negative 5x. You know, it's not the end of the world, but we like to avoid that. That's why the recommended would be add 3x to both sides. Then we keep that with a positive coefficient. 2 is greater than or equal to 5x minus 8. Okay, add 8. 10 is greater than or equal to 5x. And I'll tell you, for me, I really do like to have the variable on the left. I don't like having to solve for it on the right. So I'm going to just switch this to say 5x is less than or equal to 10. Yeah, just reverse everything. Now divide by 5. X is less than or equal to 2. Right? How would we graph that? Would it be an open or a closed circle on 2? Yeah. Because 2 is part of the solution, we close the circle on 2. Which direction do we shade, left or right? To the left. X less than or equal to 2, on the number line, less than is to the left. So shaded to the left.